Once pleated, the battery is bonded permanently to the frame.
Induction coils are connected to enable wireless power transfer.
Before it becomes a device in your pocket, it begins as raw earth, buried deep within the crust. Massive extraction units harvest the essential lithium and cobalt required for modern power cells. Tons of raw ore are shifted every hour to feed the global demand for energy density. These haulers carry the foundational elements of the logic board and chassis. Primary crushers break down the geology into manageable fragments for processing. Automated belts transport the crude material toward the first stage of refinement. Meanwhile, high-purity quartz is harvested to create the glass and silicon chips. Only the purest grains pass through, destined to become the face of the display. Aluminum ore is gathered from the red earth to forge the lightweight unibody frames. In other sectors, brine pools evaporate under the sun to concentrate conductive salts. Quality control begins here, ensuring the chemical composition is perfect for battery life. The raw elements converge at on-site processing plants for initial purification. Extreme heat transforms rough ore into high-grade aluminum blocks. These cooled blocks will eventually be milled into the sleek casing you hold. Rare earth elements are pulverized into fine powders for magnets and speakers. Logistics teams prepare the refined materials for their journey across the world. Sealed and documented, the foundation of the technology is ready to move. The raw harvest is complete. Now the journey to the manufacturing hub begins. From the mines, the materials embark on a global voyage across the oceans. Thousands of tons of components travel together, navigating complex supply chains.
Through all conditions, the flow of materials must remain unbroken and precise.
Arriving at the manufacturing hub, the cargo enters the next stage of logistics.
Fleets of trucks shuttle the refined materials to component suppliers and assembly plants. Just-in-time delivery systems ensure no delay in the production schedule.
Strict security protocols protect the intellectual property and high-value components entering the site.
Precision extends to logistics, with every shipment timed to the minute. Once verified, the cargo is released into the facility's inventory system. The receiving bay acts as the first filter for quality and organization. Raw materials are swiftly offloaded and logged into the digital tracking database.
Every single component is serialized, tracked from the moment it arrives.
Automated storage systems organize millions of parts with zero human error.
Advanced sorting logic directs materials exactly where they are needed next.
Robotic couriers ferry the parts from storage directly to the production floor. Before entering the assembly zone, materials must pass through decontamination airlocks. Dust is the enemy of microelectronics. Purification is mandatory.
We have now arrived at the heart of the operation, the clean room assembly floor. This is not just a fact. Every morning, an army of skilled technicians floods the campus for the day shift. Identity verification is instantaneous, logging the arrival of every team member. Personal items are left behind. Inside, uniformity and discipline are paramount.
The bunny suit is the first line of defense against microscopic contamination.
Static electricity can destroy a microchip, so every human charge is neutralized.
High-velocity air jets strip away the last remaining particles of dust.
The production floor is a sterile cathedral of technology, cleaner than an operating room.
All right, team, let's align our targets for today. Ready? Aye. Team briefings align the daily targets. Precision is a collective effort.
Each station is calibrated to the specific operator, tracking efficiency in real time. Tools are calibrated daily to ensure every screw is tightened to the exact micronewton. Materials arrive autonomously, exactly when the assembly process demands them.
The journey of assembly begins with the bare metal skeleton of the device.
But before assembly, the chassis must be carved from solid blocks of metal. Computer numerical control machines wait to sculpt the raw aluminum. The metal is secured with immense force to prevent microscopic vibrations. Spinning at tens of thousands of RPM, the cutters are ready to carve. The solid block is milled away, revealing the familiar curves of the device. Fresh from the mill, the chassis is precise in shape, but rough in texture. It must now be stripped of all industrial residues and oils. High-velocity jets blast away the metal shavings and cutting fluids. Air knives shear away moisture, leaving the surface chemically clean. Microscopic burrs on the edges are smoothed away by hand and machine.
Sandblasting creates the signature matte texture that aids in heat dissipation and grip.
Even the microscopic peaks and valleys of the surface must meet a standard.
Thousands of units are racked together for the electrochemical bath.
Anodization thickens the natural oxide layer, making the metal harder than steel.
Electricity forces the surface to oxidize, creating a durable, corrosion-resistant shield.
While the pores are open, the metal drinks in the dye, locking the color into the material itself.
Boiling water seals the microscopic pores, trapping the color forever.
High-speed lasers etch the branding and regulatory text with micron precision. For the premium models, robotic polishing achieves a jewelry-grade shine. Computer vision systems scan every millimeter for cosmetic imperfections. Perfection is the only standard. Anything less is recycled immediately. The housings are trayed and ready to meet their internal components. The nervous system of the device begins as a multi-layered fiberglass canvas. Solder paste is printed onto thousands of contact points with microscopic accuracy. High-speed mounting heads place tens of thousands of components per hour. The central processor, the brain of the device, is seated with absolute precision. Optical systems verify that every microscopic resistor is present and aligned.
The boards enter the reflow oven, where temperatures climb to over 200 degrees Celsius.
The paste liquefies, creating a permanent electrical bond between chip and board.
As it cools, the connections harden, locking the logic into place.
X-rays penetrate the silicon to inspect connections hidden beneath the chips. The larger panel is cut, freeing the individual logic boards for assembly.
The operating system and firmware are flashed directly onto the storage chips.
Metal shields are added to isolate radio frequencies and protect sensitive circuits. Thermal compounds are applied to draw heat away from the powerful processor. Every port and pin is tested for electrical continuity. Nanocoatings provide a layer of resistance against accidental moisture.
The brains of the operation are complete and ready for the body. They move to the convergence point, where all components will finally meet. The stage is set for the final integration of mind and matter.
The logic board is carefully lowered into the milled aluminum frame.
Precision screws anchor the processor to the heat-dissipating chassis.
The complex optical system is installed as a single, calibrated unit.
Even a single speck of dust here could ruin every photo taken.
The haptic engine is bolted down, ready to simulate the sensation of a click.
Acoustic chambers are fitted into the remaining millimeter of space.
High-density energy cells are prepared with specialized adhesive. Once pleased, the battery is bonded permanently to the frame.
Induction coils are connected to enable wireless power transfer. Biometric scanners are embedded to recognize the user's face in darkness.
A continuous adhesive seal traces the perimeter to lock out water and dust. The OLED panel, a deep pool of pixels, is readied for the final merger.
The display is tethered to the system, the final bridge before closing.
The device is sealed, sandwiching the technology inside a glass and metal vault. Calibrated pressure activates the seals, ensuring the unit is watertight. Two final screws mechanically lock the display to the frame.
For the first time, it looks like the device you know. A jolt of electricity wakes the silicon, and the operating system takes its first breath.
Isolated in soundproof chambers, the device undergoes sensory deprivation and overload.
Microphones and speakers are calibrated to ensure crystal clear audio fidelity. The display is tuned pixel by pixel to achieve perfect color accuracy.
Robotic fingers map the touch sensor, ensuring every gesture registers instantly.
The optical stabilization and focus motors are stressed and calibrated. The True Tone flash is fired to verify intensity and color temperature.
The invisible dot projector is aligned to map faces in 3 dimensions.
In the silent room, the antennas scream out to network simulators. It proves its ability to connect to the fastest global networks.
Wireless charging and payment chips are verified for proximity and efficiency.
Motion sensors are tumbled and spun to learn down from up. Physical buttons are stress tested to ensure they survive years of clicks.
The charging port must withstand thousands of insertion cycles without failure.
The digital soul of the device is now fully calibrated and resident.
All test data is wiped clean, leaving the device fresh for the user.
Having passed the gauntlet of automation, it graduates to the final polish.
A digital birth certificate is linked to its serial number, confirming its perfection. The device enters the final finishing zone, where human eyes are the ultimate judge.
Under unforgiving lights, technicians hunt for scratches invisible to the untrained eye. The tolerance between glass and metal is measured in microns, thinner than a sheet of paper. The optics are polished to ensure the first photo taken is flawless. A pristine layer of film seals the display, destined to be peeled by the user. The entire device is encapsulated to protect its finish during transit.
Unique identifiers are permanently etched, linking the hardware to the network. The packaging itself is a feat of engineering, designed for a precise unboxing experience. Every layer of the packaging is arranged to build anticipation.
Even the accessories are coiled with mathematical precision.
The stage is set for the main character.
The device is finally cradled in its packaging, safe and secure. The box is engineered to close slowly, a signature of premium packaging. A tamper-evident seal locks the contents, guaranteeing authenticity. A final weight check ensures every manual and cable is present inside.
Individual units are aggregated into master cartons for bulk transport.
The batch is labeled for a specific region of the world.
Thousands of devices accumulate, ready to be distributed to the masses. While most ship out, a few are sacrificed to ensure the fleet is invincible.
In the torture chamber, devices face the clumsiness of the real world. Steel and glass meet concrete to verify the structural integrity of the frame.
Survival is the only passing grade. The ceramic shield must hold.
Tumblers simulate years of being tossed into bags, cars, and pockets. They are drowned in pressurized tanks to guarantee the IP68 water resistance rating. Fine particulate chambers test the seals against the intrusion of dust and grit. The chassis is crushed and bent to ensure it won't warp in your back pocket. From Arctic cold to desert heat, the electronics must survive extreme thermal shock.
Every button is clicked hundreds of thousands of times to to guarantee a lifetime of tactile feedback.
Charging ports are twisted and yanked to simulate daily abuse.
The materials are tested against sweat, lotions, and oils to prevent corrosion.
Processors are pushed to their thermal limits to ensure they don't overheat under load.
Even after torture, X-rays confirm that no internal connector has come loose.
The sacrificial unit is dissected to verify that the assembly quality held up to the abuse.
With the sample surviving the gauntlet, the entire batch is cleared for dispatch.
The testing is done. Now, the logistics begin. Back on the floor, the approved units are sealed for their final journey. In this cathedral of commerce, millions of devices wait in silence for their owners. Automated systems retrieve specific batches destined for different continents.
Smart logistics sort the inventory by country, carrier, and model.
The cargo is more valuable than gold, protected by layers of physical and digital security.
Zone 4 secure.
Pallets are broken down and repacked into air freight containers for rapid transit. Dedicated freighters carry the launch day supply to distribution hubs worldwide. Crossing oceans at the speed of sound, the supply chain spans the globe overnight.
Arriving at regional hubs, the bulk shipment is fractured into individual orders.
The journey enters the final leg, the last mile to your doorstep.
Drivers navigate the final streets, carrying the technology to its destination.
From a mine in the earth to a factory floor, the journey ends at your door.
The seal is broken, and the cycle of manufacturing is complete.
A device of glass and silicon, born from thousands of steps of precision.
Behind the smooth glass lies the effort of thousands of hands and minds.
And this is how modern factories produce the iPhone from start to finish.
And that is how we build the world's most popular device.
Subscribe for more real factory breakdowns.